Alright, so we're going to uh, evaluate some functions here. Just a real quick background on this. Let's say we had the equation y is equal to 3x plus 1. If I wanted to make a graph of this equation, this is going to be a real quick and dirty graph. It's not going to be very accurate, but it'll prove my point. If I wanted to make a graph of this, I would start at the y-intercept, which is 1, and then I would go up 3 and over 1 for my slope. So I would have a positive slope, be going uphill. And it would look something like that, right? Now, if I wanted to know whether or not, where is my pen? Oh, there it is. If I wanted to know whether or not this was a function, I'd have to use the vertical line test on it. And I can see that pretty much anywhere that I slap a vertical line on this graph, the vertical line's only going to hit one spot. So that means that this is a function. It passes the vertical line test. So I could rewrite this equation using what's called function notation, and you guys have seen this before. I'm going to write f of x instead of y is equal to 3x plus 1. And this simply means that the equation is not only a relation, but it's a function because it passes the vertical line test. This f right here, this is the name of the function. And if I wanted to, I could have called it anything. I could have called it h of x, and that would have meant that my function's name was h. Most of the time people are going to use f, but you can use any letter you want. F and h, g, they're all pretty common. P is another one that you might see every once in a while. So that makes that point. So from here, what we want to do is evaluate some functions or some equations that are written in function notation. So let's start out with the function f. We're going to say f of t is equal to t cubed minus 4t, and we want to find f of 4. Alright, so this is pretty straightforward stuff. Once you see a few of these examples, it shouldn't be too bad. To evaluate, all I do is I take my function f, and everywhere I see t, I want to put this 4 in there in place of it. I'm substituting it in. So now I want to find f of 4, and so where there's a t, I put the 4. So 4 goes in parentheses. I'm cubing it, and I'm subtracting 4 times. Interesting. Subtracting 4 times 4, 4 times 4 there. So f of 4 is equal to, I follow the order of operations, 4 cubed is 64 minus 16, and therefore f of 4 is equal to 48. And I've just evaluated my function at the spot 4. Okay, or at the x value of 4. Let's go ahead and do another one here. Let's say that we have the function p of x is equal to 2 times the absolute value of 2x minus 1. Whoops. Make that absolute value there. And we want to figure out what p of negative 8 is, or evaluate this function at negative 8. Alright, so do the same thing we did last time. Fill in a negative 8 where I see the x. Put in parentheses around the negative 8. Anytime I sub a number in, I really should use parentheses. Get in the habit of doing that. And we're going to simplify here. So I'm going to work inside the absolute value symbols. They're a grouping symbol just like parentheses. So I work inside and I get negative 16 minus 1. And that becomes negative 17. And then we have to remember that absolute value makes whatever inside of it positive, so that becomes a positive 17. And so p of negative 8 is equal to 34. So my function evaluated at that value is 34. Alright, let's see here. Let's look at a few more examples. let's say I wanted to look at the function p. This time p of n is equal to n cubed plus 4 plus n. And I want to evaluate this function when p is equal to 3. So we're going to put 3 in everywhere we see n. And we have p of 3 is equal to 27 plus 4 plus 3. And therefore p of 3 is equal to 34. And we're done. Okay, pretty basic, pretty straightforward stuff there. We're not doing anything more than subbing in a number for our variable and following the order of operations. All right, let's make this a little more complicated now. Let's say we have the function p of n, and it is equal to 4n plus 5. And we want to evaluate p, our function p, whenever we're at n minus 1. So I'm going to say p of n minus 1, and so everywhere I see an n in my function, I have to replace it with n minus 1. Might seem a little strange to you, but yeah, anywhere I see that n, the n minus 1 goes in. Now, I'm not going to get a specific number for this answer here. I'm just going to simplify as much as possible. So I'm going to distribute my 4 into the parentheses, and I get 4n minus 4 plus 5. And so p of n minus 1 is equal to 4n plus 1. And that would be my final answer for this particular problem. I can't do anything else with it. Alright, let's see if we can find one that's more complicated here. Hold on, we'll pause this and come back. Alright, let's see. We'll do this. Let's say we have the function h of n. Our function is equal to 2n plus 3. And we want to find or evaluate h at negative 4n. Alright, well, everywhere we see an n, we're going to put in negative 4n in parentheses. So we do that right there. So we have h of negative 4n is equal to negative 8n plus 3. And it's actually the answer. We can't simplify any further than that. So it's about as simple as it gets when you're evaluating right there. All right.